Hi, this question is about a motion of a charged particle in a uniform electric field. But first of all, how a uniform electric field is produced and how does it looks like? So you can see in a fundamental concept that if you maintain the constant potential difference between them, so just like in our question, it is mentioned that 2.5 megavolts, 2.5 million volts is maintained constant potential difference between the plates, then you can produce this uniform electric field. What does that mean? It means that if you take any point in this vicinity, in this space, at that point electric field will remain constant and that will be uniform throughout. At that point also the electric field will be same. And if you want to find out its electric potential, electric field strength, so you can simply divide the potential difference and the distance between the plates. Now coming back to the question, let's say if this is an electron that is just released from that point, obviously it will be accelerated because of the opposite charge plate, so it will accelerate towards the higher potential. So when it will accelerate, what kinetic energy will it gain in order to cover this distance from the negative plate to the positive plate? Or even if it's not mentioned from negative to positive, we are just given the potential difference, okay? That is delta V, right? It doesn't mean that it's going from negative to positive. It can go anywhere from this point to this point, but between those 2 points the potential difference is given to us. So dear students, now in order to calculate the change in kinetic energy or the gain in kinetic energy, we need to calculate the work done, and that work done according to the work energy principle, it is equals to uh, change in kinetic energy, right? So either this charged particle will gain kinetic energy or lose kinetic energy. Equal amount of work will be done. Now, what is that amount of work done? I just want to quickly show you what is a relation between the work done and the other quantities. Now, we will start quickly from the general the formula of the work done, that says that the electric force times the displacement covered, and I assume that the angle is, now the angle is even 180, but in this case the electric force and the displacement are in the same direction, so angle is 0. So electric force is eq, and I'm writing E because E is constant. Q is a charge on electron, and S is the distance between the plates, because in my specific this example I'm assuming that it's going from a negative to positive. As I mentioned you, it is not necessary, so it is eqd. Now this E and D is equals to the potential difference. So it means that the work done in that region is always equals to the potential difference into the charge. So we are going to use exactly this thing here. So it is 2.5 multiplied by 10 to the power 6 times 1.6 times 10 to the power negative 19 is equals to the change in kinetic energy, and that will be, so it is 4 multiplied by 10 to the power negative 13 joules. Okay, and that can be written as, in a scientific notation, okay, it's already in that. So if you take the point, bring the point before 4, you can write it like this: negative 12 joules, and 10 to the power negative 12 is called pico, right? So we can say zero point 0.4 picojoule. So you have seen, and this is, by the way, the option C. So option C is the right answer. And you, now this zero point 0.4 picojoules means that whenever the electron will traverse the distance in which the potential difference is 2.5 million volts, this much energy will be the change in kinetic energy. Now this doesn't mean that it will gain kinetic energy or it will lose kinetic energy. It totally depends on the direction of that electron. If it is accelerating towards the higher potential, then it will be the gain of kinetic energy, then otherwise it will be the loss of kinetic energy.